Hi, I'm Hirokazu Tamamura from TMDU. So, infectious diseases caused by viruses such as coronavirus and HIV threaten our lives. These slides show the life cycle of HIV. Blue colors are clinical use drugs. Also, our laboratory has developed some agents shown in red colors. Recently, treatment with a cocktail of drugs, Ishii, has brought a great success. But Ishii cannot remove latently infected cells, so there is no cure. Accordingly, the removal of latently infected cells is required. I want to show shock and kill as a new therapeutic strategy. These are HIV latently infected cells. This is a factor impossible to cure because Ishii cannot remove these cells. So, removal of latently infected cells is required. Latency reversing agents, LRAs, such as protein kinase C, PKC ligands, cause reactivation. So, the use of LRAs leads to HIV transcription, protein expression, and virion production. Then, the new virus is released. This is a shock step. These cells become dead by the immune system. This is a kill step. And then, treatment with anti-HIV drugs can block new infection to normal cells. So, we want to focus LRA PKC ligand. Diacylglycerol DAG is a natural PKC ligand, so we want to use DAG derivatives. Diacylglycerol DAG has low binding affinity for PKC because this structure is flexible. On the other hand, homoester has high binding affinity for PKC because this structure is very rigid. This is a tumor promoter, so it cannot be used clinically. These three light blue circles are pharmacophores, so we want to fix three pharmacophore groups of DAG, as shown in homoester. Cyclization of DAG produces a gamma-lactone ring. We call it DAG-lactone. This is relatively rigid, so three pharmacophore groups are fixed. Conformational restriction by cyclization causes a decrease of entropic penalty and an increase of PKC binding affinity. Substitution of R1 and R2 might increase binding affinity for PKC. From DAG, initially we developed a DAG-lactone YSE028. Then we want to optimize YSE028 as an LRA. By compound modification, we got compound 2, which has high shock action, PKC activity, and hydrolytic stability. So compound 2 is a suitable LRA. Now we want to apply this research to drug development for complete cure for AIDS. In future, we would like to develop new strategies for therapeutics of emerging and re-emerging infectious diseases. Thank you for watching.